Ruth, are you not doing some band thing today?
I need to leave at like 9:50-ish.
Okay.
Hi. I got a 0 on 97, but I know that I did turn it in.
Okay. Did
Maybe
you get it back?
No.
Okay. You might want to look in those white boxes, the one that says first period. It could have just not saved.
Yeah, maybe I just need to save it.
Okay. I'll take it back and fix it.
Thank you.
I have a 0 in my worksheet too, but I'm pretty sure I turned it in. Like, I think it was because the day the bell was out, but I think I turned it in.
Yeah, it sounds like Gradebook may not have saved some of them. In those white boxes up there, and there'll be a tray for first period. Just find it in there and let me see it again.
It is Monday. Will you please join me for a minute? Thank you very much. Will you please stand as you are able for the pledge? I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Okay, so we got one little change here. Last time I saw you guys, I had warned you about an upcoming section 1.1 quiz, and turns out we're not going to do it that way. So we had just kind of changed our plan a little bit since I saw you last, which I guess is one of the downsides of going from Wednesday to Monday to see you. I still want to go ahead and give you grades for 102, 103, or 104. So at the end of class, I'll ask you to either come turn those hard copies in, or you can just turn them into Google Classroom if you haven't already. So I want to go ahead and give you points for that, and you'll still be quizzed / tested on that stuff. It'll just be later on with some other stuff that we're going to do. So sorry for the last second change on you, but you'll still be held accountable for those. So if you studied for it, then you should be prepared for it when you see the questions later. Okay, what we are looking at today is we are spending one full class period on solving quadratics. So we're going to talk about the different ways to solve a quadratic. A couple of them you don't use very often, but it's good for you to know that those are an option. We're going to review simplifying radicals, because that comes up sometimes with quadratic formula. And then we're going to work some of the easiest quadratic formula type questions I could come up with, and then slowly work our way out to the ones that we would expect you to be able to do. So on the front page, we're going to talk about the 4 ways that you can solve a quadratic. So method 1 is very uncommon. Well, first off, anytime that we're talking about solving today, that really just means where does it equal 0. But the first method only works if you have x squareds but not x's, which again is pretty uncommon. But you can pretty much just undo the arithmetic like you normally do. Undo minus with adding, undo minus with adding, undo times with divide, undo times with divide, and then of course to get rid of a square, square root. But the part that you guys need to circle and highlight here is that when you square root both sides, you have to do plus or minus the other side. So not always, but usually quadratics have 2 solutions. They can have no solutions and they can have 1 solution, but most of the time there's 2 solutions. So anytime you have just x squareds and not x's, then you can take that approach if you want to. I guess it's a little bit easier, but again, that doesn't come up very often. In fact, I don't think this comes up the rest of our handout today. Method 2, which I have down as factoring, this is a big one to me. This is what I try to do 99% of the time, because you need to be able to factor for a million other math things anyway, and factoring certainly makes solving quadratics pretty quick. Now, whether you can get it with guess and check, or you got to do the product sum method I showed you earlier this year, or you've got to do one of the other 20 other ways you can solve or factor, I don't care how you do it, but you need to make sure that you factor correctly. Always FOIL your answer, at least in your head, to make sure it goes back to what you started with. And then this equals 0 at 10, this equals 0 at -9. This equals 0 at -1/2, this equals 0 at 3. 2 solutions. And as much as I try to focus on emphasizing factoring, I don't think it was that common of a mistake, but on your last test that you guys took, I would still say probably the single most common mistake was the factoring. One of those equations, most of you guys solved it with factoring, and most people still factored it correctly, but I would still say it was the most common mistake. So make sure you're checking your factoring when you do it that method. Okay, there's also a method where you can solve by graphing. So realize if you're solving this you're trying to figure out where this equals 0. Well, where y equals 0, or when f of x equals 0, is the same thing as the x-intercept. So, not too relevant in our class because this isn't a skill that we need to test a lot, but like on the ACT, you got a calculator. You could graph this first one, and I'm going to ask that you just make a quick little sketch on your page. Looks like it goes through 4 and -5. 4, something like this. But the x-intercept, so we're looking right here, 2 x-intercepts, 2 solutions. The problem with this is sometimes your answers go through not nice whole numbers like this, and a decimal is not good enough. Sometimes you don't have a calculator, of course, and sometimes you can have imaginary answers, which we will talk about here in a bit, and imaginary answers won't show up on a graph. But here's the second one. So if we were to graph that equation, looks like it has a solution at 4 and 7. Because at 4, 6, 7, that's where y equals 0, and that's what you're solving for when you have it all on one side set equal to 0. So something like the ACT where time is super important, even if you can do these questions all the other ways, that's pretty much the fastest it's going to be. So, okay, and then that builds us up to quadratic formula. So we're going to practice a lot of these on the next couple pages, so we don't need to finish these. But what I want you to recognize is if we don't have a calculator, we can't just graph these. If it doesn't factor, which I don't think either one of these factor, then you can't do the factoring method. And you can't do the very first method we're talking about because these have x's and x squareds. Method 1 at the top of this page only worked when you had x squareds. So quadratic formula, we're not going to work these questions out because there's plenty of practice on the rest of it. This is the method that always works. If you want to only do one method, it has to be quadratic formula. The other methods are really just for convenience. Okay, now part of the problem with quadratic formula is depending on the discriminant's the thing that's under the square root, depending on how that simplifies, it can make your quadratic formula question be easy, or it could add 2 or 3 steps to it. So before we kind of get into that, we need to make sure we're all on the same page with simplifying radicals. So our top line here, I feel like you should be able to simplify these pretty quickly. Perfect squares, but then let's slow down a little bit and think about why these are equal to that so that we can apply that to the questions below it. So square root of 25 is like the square root of 5 times 5, and because you have 2 of the same thing under your radical, that's where you get that as an answer. 16 can be thought of as 4 times 4, you've got 2 4s. 10 times 10, you've got 2 10s. 7 times 7, you've got 2 7s. So on a question like 125, that's not a perfect square. You've got a couple options. I'm going to focus mainly on the one I want you to know, but I will also refer to how your Algebra 2 teacher may have done it. I like to do what's called a factor tree. Just find 2 numbers that go into it evenly. Doesn't matter which 2, but if it's a prime number, you quit, and if it's not a prime number, you have to break it down into 2 more numbers. This in red is referred to as prime factorization. Prime numbers that you can multiply together to get that value. Now, when we do a square root, this is like a lot of times in math, there's a lot of invisible math. When we say x, we all know that we're talking about 1x to the first. There's a lot of things that we just assume. With square roots, there's an understood index of 2, which just tells us that we have to have 2 of the same thing for them to group up and come out front. And then if there's anything left behind, then it stays under the radical. So the square root of 125 is 5 square roots of 5. 27, we could break down into 3 times 9. 3 is prime, but 9 is not. And now they're all prime. So a different way to look at 27 is 3 times 3 times 3. And since it's a square root, we need 2 of the same things to group up to come out front. And then it looks like there was one more 3 left behind. So instead of saying the square root of 27, we would say 3 square roots of 3. Okay, 8 is a little bit easier just because it's a smaller number. 8 is 2 times 2 times 2. So this guy simplifies as 2 square roots of 2. Sometimes the decimal is fine, but a lot of times it's not. And simplifying in the quadratic formula, which we're going to be doing on the next page, we need to be able to break these down like this. Okay, let's look at one more of these, and then I want to save the next 4 for you guys to come back and do at the end of class. I want you to have to think about them again. Okay, so my preference would be for you to do this. Do the factor tree, find any 2 numbers that go into 12, find any 2 numbers that go into 3, realize that 12 is the same thing as 2 times 2 times 3. You've got 2 2's, so they can group up and come out. You had a 3 that had no one to pair up with, so you get 2 square roots of 3. Now, the reason why I like this method, and I'm going to focus on this method, is because, did you guys do any like cube roots or fourth roots in Algebra 2? Mm-hmm. Okay, so when you need to do cube roots and fourth roots and fifth roots, even if you didn't do those in Algebra 2, the only difference is if it's a cube root, you need 3 of the same thing to group up and come out. If it's a fourth root, you need 4 of the same thing. If it's a fifth root, you need 5 of the same thing. So this method is easy to apply to those. That being said, I know some of you learned it this way last year, and this would be fine for today too. Some teachers like to show it as find the biggest perfect square that goes into this evenly. So instead of calling it the square root of 12, you can think of it as the square root of 4 times the square root of 3. And that's helpful because the square root of 4 you can do in your head, and the square root of 3, hopefully you can see doesn't simplify, but you get the same thing. So that's fine to do with square roots if your brain works that way, but this method, someday when you have to do cube roots and fourth roots and stuff, college algebra or something, it'll be a little bit easier to extract. This method's really hard to do with cube roots and fourth roots. But if you want to do that on your paper today, I have no issues with that. Okay, so I'm saving the next 4 of those for you to do. Let's skip down to what happens when we get the square root of -1. This is what we call the number I for imaginary. Now, we don't really review imaginary numbers much in here, just because imaginary numbers are not a big deal in calculus, and of course this is pre-calculus. But just so you guys are aware, they're called imaginary, but they certainly exist. My understanding is, like with mathematics, usually the first person to like write up the paper is a person who gets to like pick the names and pick the notations and all that kind of stuff. And when that mathematician did the work and the documentation behind this stuff, it was a long time ago, and we didn't use these numbers, so he didn't think that they would be needed, which is where the name imaginary came from. But then years later we figured out that we did. Imaginary numbers, like pretty much any circuit board, cell phone, computer, they all use this kind of stuff, so the name's a little bit misleading. But as far as what we need them for today, very easy. It just adds 1 step to what we're doing. So if you know the square root of 4 is 2, then the square root of -4 would just be 2i. Just bring the negative out as an I, and then simplify your radical the same way you always do. Always bring out the negative as an I first, so you don't forget about it, and then the square root of 81 is still 9. So I'm going to do one more row with you. But again, the I part isn't really harder, it's just one more thing you have to memorize. So for 216, I would, bless you, I'm going to do the factor tree. So find any two numbers that go into it, and then the numbers get smaller and smaller, and it gets easier as the numbers get smaller. But it looks like I already brought the negative out as an I, so that's already taken care of. And then 216 is a big number, so 2 times 2 times 2 times 3 times 3 times 3. I've got a pair of 2's that can come out, a pair of 3's that can come out. Everything that comes out gets multiplied together, so we're left with 3 times 2 times I, and everything that gets left behind gets multiplied together. There was a 2 and a 3 that didn't have anyone to pair up with, so those both got left behind. Everything that comes out front gets multiplied together, everything left behind gets multiplied together. So 26, let's take out the I before we forget, and then it's going to work out the same way. Looks like 28 is 2 times 2 times 7, so in the end, 2I square root of 7. 2 2's under the radical, pair up and become 1 2 outside of the radical. Bring the negative out as an I. I'm going to cheat a little bit on this one. 6 and 6 are not really prime numbers. This is not really its prime factorization. But if it's got 2 6's, we can bring one out. So you'd end up with the same thing either way. And negative 150. Bring out the I, and then simplify the square root of 150 the same way. Looks like 150 is 2 times 5 times 3 times 5. There's a pair of 5's and a 2 and a 3 left behind. So I'm zipping through that part pretty quickly, but I know you guys have done that in the past. Is there anything you want to ask about this before we jump to the next page? Okay, the third page is the one we're going to have to slow down a little bit on, because now we're going to actually execute the quadratic formula. And again, it's going to kind of start off with questions that I think work out as nice as possible, then ones that are a little bit messier, and then finally ones that are a little bit messier. But no matter how hard a quadratic formula question is going to be, step one is always you have to know the quadratic formula. If you misremember it or get part of it wrong, then of course your answer is not going to come out. So negative b plus or minus the square root of b squared minus 4ac all over 2a. I would recommend that you write it down every question until you are sure that you have it memorized correctly. That repetition will help. Okay, step 2 is make sure it's in standard form, which means everything on one side set equal to 0. And then a will be the coefficient of x squared. Just means the number that's being multiplied by x squared is a. B is the coefficient of x, and c is the constant. So you need to pick out a, b, and c. And then the last step, which varies greatly, is simplify. Simplify can be quick and easy, or it can be 3 or 4 steps and be kind of messy. But that's what we're going to look at on this page. Okay, so the ones that work out as nice as possible, if this is equal to 0, I can see a is 1, the coefficient of x squared, b is negative 10, the coefficient of x, and c is the constant. I know the quadratic formula and I have it written at the top of the page, so I'm going to just jump straight to that. Opposite of b plus or minus the square root of b squared minus 4 AC over 2A. So that's what's going to be consistent with all of the questions. This is where you need to slow down a bit. Now, I guess the denominator 2 times 1 is not a big deal, but generally speaking, with quadratic formula, I would say by far the vast majority of the mistakes come from this, what's called the discriminant. So we're going to try to do all these without a calculator, but we need to be extra careful here. And minus 4 times 1 times negative 11 is like a plus 44. So 100 plus 44 is 144. And then this one works out nicely because the square root of 144 is a perfect square. It's 12. So one answer comes from 10 plus 12 divided by 2, and the other one comes from 10 minus 12 divided by 2. So 11 and negative 1. And of course, I could have factored this one, which would have been a lot faster, but again, we're just focused on quadratic formula back here. But the discriminant that I have highlighted, that arithmetic is usually the cause of errors. So don't go too fast on that part. Okay, so another one that should work out just as nicely. A is 1, B is negative 10, and C is 21. Plug them in the quadratic formula as it says. Negative b plus or minus b squared minus 4ac over 2a. And then slow down right here. We got 100 minus 84, which would be 16. And then again, this discriminant, it kind of determines how much more work we're going to have to do, because the square root of 16 is a nice even 4. One answer is going to come from 10 plus 4 over 2, and one's going to come from 10 minus 4 over 2. So 7 and 3. Okay, all that seem familiar before we take it one step further? Okay. Did y'all do a lot of this in Algebra 2 or just a little bit? A lot? Probably the most important formula from Algebra 2 at least. Yeah, to be honest, we don't use it in calculus a ton, but the thing is, when you need it, there's really no substitute. So, okay. So now 31 is going to look the same, but you're going to see that it's going to take a little bit more work at the end. The simplifying step is going to be a little bit worse. Step 1 is still memorize quadratic formula. Step 2 is still pick out A, B, and C and plug them in correctly. Nothing seems any more difficult until we get to discriminant, and it looks like the discriminant is negative 99. So unlike the top two questions, this doesn't come out perfectly. So it's a little bit less comfortable. But we can bring the negative out as an I. We can reduce the square root of 99 into 3 square roots of 11. And then there is our two solutions. 1 plus 3i squared of 11 over 10 and 1 minus 3i squared of 11 over 10. Also, because this has I in the answer, because this is an imaginary solution, that means that his solutions do not show up as x-intercepts. If you graph that equation, it does not cross the x-axis. That doesn't mean that he doesn't have solutions, though. They just have to be imaginary solutions. I just pointed out to you so that you realize that graphing calculator can't do everything. Okay, so simplifying of the discriminant just made that a little bit more work.
Wait, so could you just leave it like that? And then
Right here?
Yeah.
Yes. Yep, there's nothing else to be done right here. I guess one thing you could do, it's not better, it's just different. If you really want to split apart your fraction, you could say you've got 1/10 plus or minus 3i square roots of 11/10. Those are equivalent though. This isn't better, so I don't usually take an extra step to write it that way. Okay, and then one more, that's this difficulty before we take it one step further. And then that should be what you were expected to do. So step 1 doesn't change, step 2 doesn't change. Plug them in carefully. Last period I did plug in one number wrong, which isn't too bad considering how many questions there are here, but still. Opposite b plus or minus b squared minus 4ac over 2a. So all of that is very, I don't know, systematic. Very similar steps from question to question. But then you got to slow down right here with the discriminant. Got 16 plus, negative times a negative is plus, 4 times 1 times a half would be 2. 16 plus 2 would be 18. Make sure you're doing order of operations there. And then because 18 is not a perfect square, unfortunately this is just a tiny bit more work. I would have to break this guy down like we did on the last page into 3 square roots of 2. And then there's our answer. Negative 4 plus 3 square roots of 2 over negative 2, and negative 4 minus 3 square roots of 2 over negative 2. Okay, and then finally, to take one more step closer to what we need to be able to do, this number 33 is kind of out of place. We're going to skip that one. It doesn't fit what I want you to do here. So we start 34, and again, it doesn't look any different. Quadratic formula hasn't changed. How to find A, B, and C hasn't changed. How to plug them in hasn't changed. Being careful about the discriminant hasn't changed. Let's see, 16 minus 8 would be 8. Simplifying your radical hasn't changed. Now this one, again, you can do the factor tree. We did it on the other page though, and I just know that one, so I can go straight to it's 2 square roots of 2. What makes this one different than the last section we just did though is this still needs to be reduced. Just like you wouldn't leave a fraction 5 over 25, both of these divide by 5, so you divide them both by 5. Well, every term in this one is divisible by 2, so to reduce your fraction, you should divide everything by 2. This gets divided by 2, this gets divided by 2, and this gets divided by 2. So it's just simplifying fraction. It doesn't look like it. It looks more complicated, but that's all we're really doing. Also right here, be careful. We've got 2 square roots of 2. Square roots of 2 are what they are. So if you divide that in half, you're left with 1 square root of 2. But you don't divide the thing under the radical as well. Okay, another way to think of this, if you have a hard time seeing why that works, is I'll write it out here. It's just kind of weird. But out of the numerator here, we could have factored out a 2. And then I think it's a little easier for you to see why we need to take this 2 and reduce it with this. And you can see it's the same thing. But reducing your fraction is important. ACT is never going to make the final answer look like this. They're going to reduce the fraction and make it look like this. Okay, so to see that again, 24 minus 28. Negative 24. So this breaks down as all radicals do. Well, not all, but a lot of them do. Just because it's not a perfect square doesn't mean it doesn't break down. So 24 is 2 times 12, which is 2 times 6, which is 2 times 3. So the square root of 24 would be 2 square root of 6. But because it was negative 24, it needs to be 2i square root of 6. And then again, in this section, I'm trying to get you to see that sometimes you need to reduce your fraction. This term, and this term. All of the terms are divisible by 2, so divide them all by 2. And of course, we don't need to leave it over 1, so we'd want our answer to look like this. I know you guys can do that, it's just that a lot of times y'all don't think about that if I don't emphasize it. So. Okay, we still good? Okay, let's look at one more together, and then I will show you a way that you can check your answers even when your answers look really weird like that. So, and then I'll ask you to go back and skip or do those other simplifying radical questions that we skipped, and then there's 6 of these on the back page that I'd like you to do. So, okay, negative b plus or minus b squared minus 4ac over 2a. I need to check that because my brain was going weird there for a second. Alright, this would be 36 minus 40, which would be negative 4. So the square root of 4 would be 2. But since it's negative 4, it's 2i. And then some questions don't go further, like in the middle of this page, but sometimes they do. 6, 2i, and 10 are all divisible by 2. So divide every term by 2 is how you're going to reduce that fraction. Again, it's like taking out a GCF out of the top and then dividing it with the denominator. Okay, I want to remind you though that you can check your answers to these, especially the back page, as you do them, because some of those answers will look kind of messy, with your calculator. So even when you have I in your answer, with the store button, we can have our calculator do this. So I'm going to ask my calculator, what is 3 plus I over 5? Store that as x. I'm going to show you in just a second. I just can't. I need to see the question before I move it. And then it's supposed to make the original equation. So I'm storing my answer in for x. Even though I had an I in there, you can still do that. I is right here. It's not this I. This I is for like typing messages and words and stuff. The I number is second decimal down here. So I stored that in for x, and it's supposed to make the original equation equal to what? So even though that answer looks kind of strange, it doesn't take but just a second to type it in and confirm. Also, imaginary zeros always come in conjugate pairs, so I know the conjugate's going to work as well, but if you feel better by storing the other part of the answer, because remember it's plus or minus, you can also check to make sure that it works as well. So you don't have to just hope that your answers are correct. You can certainly check, and it doesn't take very long with the store button. Okay, so I've got 8 of those simplifying radicals I'd like you to do, and then in the back page I've got 6 questions where I think you need quadratic formula. The last hint I want to give you before I get out of your way and start let you see how this is going to work out. Be careful with quadratic formula that you don't fall into this mistake and say that A is -9, C is -7, and B is -10. You can only pick out A, B, and C if this is in standard form. So you either need to move all of this to the right or all of it to the left. And it does not matter, but I'm going to add this over and add this over. It has to be in standard form before you pick out your A, B, and C. Because if some of those signs are wrong, then you're working a different question. Your answer is never going to work. Or you'd have to be very, very lucky for it to coincidentally work. Okay, so you don't have to worry about the 2 questions on the front page. Again, I was just mentioning quadratic formula as a strategy. I do want you to finish page 2, simplifying the radicals, and I do want you to try these 6, because if you can do these 6, then you can do anything we would throw at you on a test as far as quadratic formula goes. So please let me know if you have some questions. And I will remind you that if you didn't turn in 102, 103, and 104, please make sure you give me your hard copies or go ahead and put them in Google Classroom today. I do want those. I do want to go ahead and get those grades put in. So, at any point in class today, please do that.
I had a 0 for number 97 and I found it in the box grades.
I think gradebook must have gone down when I was typing those in or
I
something.
think so too. I think it was Monday.
Yep.
I haven't done the log true false quiz.
Okay.
Could I do that right now?
And you can answer these however you want to, but I did tell them that there was 7 true answers and 10 false answers.
Okay.